Hello, this is Captain Chaudhari. In my series of videos on basic stability calculations, today I'm going to do the calculations about the stability of a raft. In my last video, we did a raft that was made up of drums and a horizontal platform on top. The drums were horizontal. Now, in this particular numerical, this numerical is again from my book. We've got 4 drums, each of diameter 2.4 meters, making the raft with the platform on top. The axes are vertical, axis to axis. Separation is 3.4 meters at forward as well as aft end. This way, the length of the raft is 6 meters and breadth is 5.8 meters. The kg of the raft overall is 0.9 meters and draft is 1.4 meters. So if we look at the plan view, the raft length is 6 meters and the breadth is 5.8 meters. The diameter is 2.4. 2.4 multiplied by 2 is 4.8. That means there is a gap of 1 meter in between the raft. So if we, in a plan view, look at the 4 drums, they would appear like this. There's a gap of 1 meter in between. The length of the raft is 6 meters. This is 5.8 meters. 2.4 plus 2.4 is 4.8. That means this gap is 1.2 meters. Right? So this is how the plan view of the raft would look. This is of course a wooden platform on top, and this is the common center line. Now if we look at the raft from the sides, drums being vertical, the draft is 2.4 meters, draft is 1.4 meters, right? Let us find out underwater volume. So, waterplane area of one drum is pi r square. That is 3.14 into 1.2 square. Now, this is the waterplane area of one drum. If it is 4 drums, then I'll have to multiply by 4. So it becomes 1.2 into 1.2 into 3.14 into 4. So total waterplane area is 18.0864, right? And this multiplied by draft, that is 1.4, will give me the underwater volume, that is 25. So underwater volume will be total waterplane area multiplied by draft, so that is 25.321 meter cube. Okay, so this is the underwater volume. We'll make a note of underwater volume. Underwater volume is 25.321 meter cube, and also the waterplane area, the total waterplane area or waterplane area of one drum, waterplane area of one drum, 4.522, and total waterplane area is equal to 18.0864. If the draft is 1.4 meters, we can say that the kb of the raft is 0.7 meters. We also have the kg of the raft, that is 0.9 meters. The only thing which we don't know is what is the BM transverse. As you know, BM transverse is moment of inertia. Moment of inertia of the waterplane area about the common center line divided by underwater volume. We have underwater volume. what is the moment of inertia of one drum about own axis? So I would say pi d raised to 4 upon 64, right? Now I want moment of inertia about a remote axis, which is different than the axis passing through the centroid. And as I told you, this gap is 1 meter. That means this gap is 0.5 meters from the common center line. This is 0.5 and the radius is 1.2. This is 0.5, this is 1.2, total distance is 1.7. So moment of inertia of one drum about common center line will be area of one drum. Area of one drum is 4.522 multiplied by the distance square. As I said, this is 1.2 plus 0.5, 1.7 square. And the total moment of inertia of all the 4 drums about the common center line, I will have to multiply everything by 4. So let us see how much you get. Pi d raised to 4. D is 2.4 meters. So 2.4 into 2.4 into 2.4 into 2.4 is d raised to 4 into 3.14 equals, divided by 64, 1.628 plus 4.522, 1.7 into 1.7 into 0.068, 13.068. The total multiplied by 4, 58.786 or 58. That is the total moment of inertia of waterplane area about the common center line, that is 58.786. Now this total moment of inertia divided by underwater volume. Underwater volume is 25.321, right? So divide by 25.321 gives me BM as 2.322. BM transverse as 2.322. So I'll write it here. BM transverse is equal to 2.322 plus KB. KB is 2.322 plus 0.7 gives me Km as 3.022 minus Kg minus 0.9 gives me GM as 2.122. So this is how we find out the GM of raft that is made up of 4 vertical drums. So the main calculation here is, if we look at the waterplane area, or if we cut the raft along the water line, you will find the transverse waterplane areas to be like this, 4 circles. Now the main calculation is, what is the moment of inertia of this one waterplane area, circular waterplane area about the own axis, that is pi d raised to 4 upon 64. If I transfer it to the common center line, I get some moment of inertia about the common center line. If I multiply by 4, I get total moment of inertia contributed by the circular planes about the common center line. And we know total moment of inertia divided by underwater volume gives you BM transverse.